Part 1. The Battlefield of Thermodynamics. Picture a silent winter forest, snow drifting through the trees, every breath rising like smoke from a dying fire. The cold is already at 18 degrees Fahrenheit, -8 Celsius, and sinking fast. By 3 in the morning, it will be deep into the kill zone. Most people see nothing but trees and open ground, but I see something else entirely. I see a battlefield. Because out here, thermodynamics is the hunter, and anything warm, anything alive, is its prey. Every calorie your body produces tonight is already being stripped away, and just one rookie mistake means you won't see the sunrise. For decades, survival books taught us one golden rule: build a debris hut. They called it the ultimate primitive shelter. But I'm here to tell you the truth. Stop building them the old way. Even a modern nylon tent won't save you in conditions like these. Not because you're inexperienced, but because physics doesn't care. Tonight isn't about camping. It's about engineering a system, one that manufactures its own microclimate. A structure that uses thermal mass, dead airspace, shape, and camouflage to stay up to 50 degrees Fahrenheit warmer than the world outside, without a sleeping bag and without a fire burning inside. This is survival through science, not luck. So the question is, are you ready to turn the laws of the universe into your allies? If you are, then let's begin. Part 2. The Hidden Enemy, Gravity and the Cold Sinks. Before you pick up a single branch or plan a single wall of your shelter, you must confront the first killer of winter survival. And it isn't the temperature, it's gravity. Most people never realize this, but air behaves like a fluid. Cold air is heavier than warm air, and when night falls and the ground radiates its heat into the sky, that cold air begins to flow downhill. Quietly, relentlessly, just like an invisible river. Those beautiful valleys you're tempted to camp in, they are death traps. They are what scientists call cold sinks. I've measured it myself, a 15-degree temperature difference between a riverbed and a point less than 70 feet higher on the slope. 15 degrees, simply because gravity pulled cold air downward and pulled it where you thought you'd be safest. So here's your first hard truth. If you camp near water in winter, you are not sleeping beside a peaceful river. You are lying inside a natural freezer filled with moisture. And moisture is merciless. It strips heat from your body 25 times faster than dry air ever could. But escaping to the mountaintop won't save you either. Up there, the wind becomes a blade. It accelerates over ridges and peaks, ripping heat away through convection faster than your body can produce it. You survive neither the bottom nor the top. So where is the real sanctuary? Geologists call it the thermal belt, an invisible ribbon running along the middle third of a slope. It sits above the valley's freezing moisture and below the mountain's cutting winds. And in that narrow band, temperatures can remain dramatically higher through the night. This is why our ancestors, hunter-gatherers who read the land like a language, chose caves and shelters carved into mid-mountain cliffs instead of setting camp on the inviting valley floor. They understood something modern people have forgotten. Survival begins long before you build anything. It begins with choosing the right battlefield. And now that you know where warmth hides, we can start learning how to build a shelter that doesn't just protect you, but works with the physics of the land itself. Part 3. The Foundation Technique. Don't let the earth steal your heat. Now look down, because beneath your boots lies one of the most efficient thieves in all of nature, the ground. In winter survival, conduction is the silent assassin. Heat always flows from warm to cold, and the frozen earth beneath you is an endless reservoir of cold. The moment you lie down unprotected, the ground begins pulling heat from your body, especially through the femoral arteries in your thighs, faster than you can possibly replace it. You won't even realize it's happening until it's too late. This is why scraping the soil flat before you sleep is not preparation. It's a fatal mistake. What you need isn't a cleared surface, it's a barrier. A dielectric barrier that interrupts the transfer of heat between your body and the planet below you. So instead of bare earth, we build a foundation using only dry materials, pine needles, dry ferns, loose leaf litter. Anything light, airy, and moisture-free. And we don't sprinkle a thin layer. We create a mattress, a real one. You need at least 12 inches, 30 centimeters of loose insulation beneath you. Not for comfort, but for physics. Because when your body weight compresses it, that 12 inches will shrink to about 4 inches of trapped, motionless air. And dead air is the greatest natural insulator you have access to in the wild. This isn't a bed, it's a severed connection. It disconnects your core temperature from the freezing mass of the earth, keeping your heat where it belongs, inside you. When people think survival starts with walls or roofs, they're wrong. Survival starts with the ground. Master this, and you've already won the first battle against the cold. Now that the foundation is set, we can move on to shaping the structure that will hold your microclimate together. Part 4. The construction technique, the geometry of survival. Once the ground is insulated and the cold has lost its first advantage, it's time to raise the structure itself. And in winter survival, geometry is not decoration. Geometry is life. Every shelter has a spine, and for this one, it is the ridge pole. This is the backbone that carries the weight of the entire system, so choose it wisely. Never use green wood. Fresh timber bends, it smells, and it leaves obvious scars in the forest signs you never want to leave behind. Instead, look for dead standing wood. It's already dry, already hardened, and it blends seamlessly with the landscape. Now pay attention to the height. The ridge pole should sit right at your waist. Too low, and moisture will condense above you and drip onto everything you own. Too high, and you'll waste precious body heat trying to warm empty space that gives you nothing in return. Survival is always a negotiation with physics, and height is one of those negotiations. From this spine, we attach the ribs. These branches should angle down at 45 degrees, the perfect slope to shed rain and snow, and the perfect resistance against tearing winter winds. They must be tight, no gap wider than the width of your hand. Every opening is a heat leak, and every leak is a threat. And here is a small detail that separates the experienced from the desperate. Any small branch pointing inward must be snapped off immediately. One unnoticed spike pressing into your back can ruin your sleep, and in survival, sleep is currency. It restores your mind, sharpens judgment, and keeps fear from taking over. Outward-facing branches, however, are valuable. They anchor your insulation layers so they stay in place through the night. This is more than building a hut. It's designing a vessel that traps heat, resists weather, and cooperates with the laws of nature instead of fighting them. Once the geometry is set, we can begin crafting the outer shell, the barrier that will transform this frame into a true microclimate engine. Part 5. The secret of insulation, the 3-foot shell. Now that the frame is standing, it's time to give this shelter its true power. And that power does not come from wood or skill or even your own body heat. It comes from insulation, real insulation built with intention and physics in mind. So don't simply throw leaves onto the structure, build them like armor. Start with a layer of thick bark, the kind that naturally repels water and blocks ground moisture from creeping upward. Then begin piling on dry leaves, compressing them as you go. You're not decorating a hut, you're engineering a barrier that separates survival from hypothermia. Our goal is a full 3 feet of insulation on every side, nearly 1 meter. It sounds excessive, but that thickness forces the dew point far outside the living space. And when the dew point sits outside the shelter, moisture condenses out there, not where you sleep. Dry insulation means survival. Wet insulation means a death sentence. It's that simple. Once the layers are in place, take a step back. At this stage, the shelter still looks unnaturally geometric, almost man-made. But nature hates straight lines, and a shelter that stands out is a shelter that fails, whether you're avoiding wind, predators, or simply the gaze of an approaching storm. So we break the outline, toss large branches and deadfall logs over the frame in random patterns, throw handfuls of forest duff into the air and let it settle naturally across the surface. From 50 feet away, the entire structure dissolves into the landscape, disguised as nothing more than a mound of forest debris. This is no longer just a hut. It is a micro-environment camouflaged, insulated, and engineered to hold warmth where physics says it shouldn't exist. And now that the shell is complete, it's time to do something even more powerful. Charge your shelter with stored heat, using a trick straight from the laws of thermodynamics. Part 6. The thermal battery. When heat physics becomes your ally. With the shelter built and the insulation sealed tight, there is still one final problem. Air can hold heat, but it cannot create it. Your body puts out about 100 watts, just enough to keep you alive, but nowhere near enough to keep you truly warm through a winter night. And lighting a fire inside the shelter, that is not survival, that is suicide. Smoke reveals your position to anything or anyone watching. Worse, carbon monoxide seeps silently into your bloodstream, turning every breath into poison long before you even realize something is wrong. So instead of burning fuel beside your bed, we borrow energy from the oldest principle in physics: heat transfer. Far away from the shelter, 180 meters, roughly 200 yards, you build a small, intense fire. And into that fire you place dense stones, basalt, granite, or any igneous rock that has survived centuries of pressure and heat. These stones are not decoration. They are your thermal batteries. But here is a warning you cannot afford to ignore. Never heat porous stones, river stones, limestone, or sandstone. Water trapped inside microscopic cavities will flash into steam when superheated. Steam expands 1,700 times its volume. The result is an explosion so violent that shards of rock become shrapnel, fired outward at lethal speeds. 2 hours of heating is all it takes for a calm stone to become a grenade. Choose the right stones and heat them until they glow with stored energy. Then wrap them tightly in fresh bark to protect your hands and slow the heat loss. The fire stays behind, but the energy comes with you. Carry the stones back to your shelter while they're still radiating warmth. Dig shallow pits, about 2 inches deep, into the center of the shelter floor and bury the stones beneath a thin layer of earth. Now you've transformed your primitive shelter into a radiant heating system. The same principle used in modern homes, but with zero electricity, zero fuel, and zero smoke. The soil acts like a governor, releasing the heat slowly and steadily for 6 to 8 hours. No flames, no glow, no scent, just quiet, invisible warmth spreading upward while the world outside falls further below freezing. This is where modern camping ends and real survival engineering begins. You are no longer fighting the cold, you are harnessing physics to defeat it. Part 7. The ventilation system. Don't turn your shelter into a coffin. Now that your shelter is insulated, camouflaged, and charged with radiant heat, there's one last element that stands between comfort and catastrophe: ventilation. Because a shelter sealed too tightly doesn't become warmer, it becomes a coffin. When you sleep, oxygen levels drop and carbon dioxide rises. Your breath slowly poisons the space around you. But the solution isn't to open the shelter and let the wind rip your warmth away. The solution is to use physics again, quietly, elegantly, and with purpose. So we begin by creating a low intake vent near where your head will rest. Cold air is dense, and gravity pulls it downward. By giving it a small entry point close to the floor, you invite a gentle, controlled trickle of fresh air into the shelter. Then, at the top of the structure, you loosen a small gap, just enough for warm air to escape upward. Warm air always rises, and as it drifts out of the upper vent, it pulls fresh air through the lower one. This creates a passive convection loop, powered entirely by the heat of your own body. No fire, no electronics, just the laws of nature working on your behalf. To finish the system, you seal the entrance with a debris-filled wedge plug. The harder you pull it into place, the tighter it locks. It works like a primitive airlock, preventing drafts while keeping the shelter airtight everywhere except the vents you chose. What you've built isn't a pile of leaves, it's a controlled atmosphere. Fresh air enters exactly where you want it. Stale air leaves exactly where you direct it. And not a single degree of precious heat is wasted. This is the difference between hoping to survive the night and engineering the conditions that guarantee it. And once the air is moving the way physics intends, the shelter becomes more than protection. It becomes a living system, breathing, heating and sustaining you, while the world outside freezes solid. Part 8. The results and the lessons for our modern world. Night has fallen completely now. The forest outside is locked in silence, and the cold has reached its full strength. The thermometer just beyond the shelter wall reads 12 degrees Fahrenheit, minus 11 Celsius. Yet inside, the numbers tell a different story. 68 degrees Fahrenheit, 20 Celsius. Warm enough that I'm lying here in a thin shirt, not shivering, not bracing, simply breathing. It's almost unbelievable. No fire burning beside me, no sleeping bag wrapped around me. Just physics, quiet, relentless physics, doing exactly what it has always done. By 4 in the morning, the stones beneath the floor will begin to cool, but the thermal mass of the entire shelter will have stabilized. The warmth lingers, the air stays dry, and I can fall into a deep, restorative sleep, the kind your body needs when it's navigating a hostile environment. And that is the line between survival and dominance. Survival is reacting to danger. Dominance is designing your environment so the danger never reaches you. Cold destroys your ability to think clearly, but real sleep restores it. In the wilderness, your mind is your greatest asset, and this shelter exists to protect it long before it protects your body. When dawn finally arrives, I collapse the shelter, scatter the debris, and smooth the forest floor. Within minutes, the place looks untouched, as if no human ever slept here at all. And this, too, is part of the art. A shelter that keeps you alive should also be one that disappears without a trace. So what does all of this mean for us today? People living in cities, suburbs, houses warmed with electricity and gas. It means we've grown comfortable relying on systems we barely understand. It means we often outsource our safety, our knowledge, our resilience to technology. And it means that if those systems ever falter, most people will panic long before they think. But survival has never been about fighting nature. Nature always wins that war. Survival is about understanding invisible forces, gravity, radiant heat, vapor pressure, convection, and turning them from enemies into allies. It's about observing how the world actually works, not how we wish it worked. And once you understand those forces, you stop trying to survive. You start engineering outcomes. So I leave you with this question. If everything you depend on disappeared tonight, heat, power, fuel, comfort, would you know how to build a microclimate that keeps you alive until morning? Don't just build huts, build systems. Learn physics, study history, and you will begin to master the environment the way our ancestors did, not through luck, but through understanding. If you found this journey valuable, don't forget to like the video and subscribe to Historia Prime. And leave a comment below. Which survival skill should we break apart with science in the next episode? I'm Historia Prime. Thank you for watching. Stay warm, stay alert, and I'll see you in the next expedition.